So this is the standard view of Camunda in our browser. And let's just go ahead and jump into the task list. Here the employee can start his processes and sees all his tasks. So let's just start a sample task. This is the task which you can also find in the demo paper. So before we begin, let's just have a quick look at this process. Let me just show you on some slides. As you can see, there are two tasks and they each are assigned to a DMN table, and as we will see, the DMN tables are inconsistent. Let's see what happens if the employee enters the instance data Bob. As you can see, there was an inconsistency detected in task 2, which is where the error occurred. So the user can now go ahead and click on the newly created plugin tab. Here we see an overview of the inconsistencies on the top, and you can also see in the DRD the respective tables are marked red, which means they contain inconsistent rules. These are the tables from the example. The user can now go ahead and click on these tables, see where the errors are, and the colors correspond to above. We can see in table 2 there's an inconsistent rule, which is marked in blue. You can also go ahead and click around and just take a look at how the inconsistencies are, where they are. And on top here, you can see the inconsistency analysis, which provides quantitative insights. We will talk about this later. Before we can see how we can fix this, let's go into the so-called Camunda cockpit, which is a management dashboard. Here we have seamlessly integrated the inconsistencies as incidents. As you can see, the admin or manager can now see these incidents which occurred. We see there's an error in the DMN table, he's alerted, and he can now use his usual environment to try and resolve this. As always, he can see, for example, the people who were assigned and can try to find them, contact them, and try to resolve the issues. Let's jump back to the Camunda task list and try to resolve the inconsistencies. So we can directly go into the tab again, and we integrated DMN.js, which is a JavaScript library to edit DMN tables, and the user can now edit tables directly in the browser. Let's just change this to false. We can save this change now, which means that this DMN table is now directly deployed, and we see this was deployed successfully. And now we see that Camunda, because of the error in task 2, it rolled back to the last user task. This is the standard behavior. This ensures that we don't have any compliance breaches, and we stop the automated process execution and jump back to the last correct user input task and try it again from there. So now if we resubmit this, we can see that the task was successfully performed. It disappeared from the user's task list, and also in the Camunda cockpit, we don't have any incidents anymore. I'd like to show you how this works in depth, so let's go back to our slide deck. If the user starts a new process instance by entering the customer data Bob, we start a new process instance. You can see this token here, and the process engine forwards this token through the process model. If we reach task 1, the rule engine will consult the DMN table and try to make a decision. This is stored in the so-called decision history. To store this, we transform the DMN rule into a logic formalism entitled FCL, so we have an FCL transformation here. And now we have this decision history. We check this now for consistency. As you can see, it's still only one rule, so everything is fine. So the process engine will then is finished with task 1 and will route the token to task 2. Here we consult the DMN table again, or the rule engine again, and this DMN rule here is again transformed and stored in the decision history. Now if we check the decision history for consistency, we see that we have contradictory outcomes for the customer Bob, and this is the inconsistency, and here we have detected this inconsistency here in task 2 via the decision history. So you might be wondering why we are using a decision history. This is because our approach is geared towards helping companies detect inconsistencies at runtime, and here the decision history is crucial for helping us to identify which tables we have to compare. Because we don't want to compare all tables at runtime because this is expensive computationally, and here this is why we need the decision history to store for one process instance which tables we need to compare for consistency. This will be clarified in an example. So here we have another sample BPMN model, and we have assigned a DMN table to task A. And if we start a new process instance now with the data Bob, we will see that we consult this DMN table via the rule engine, and the outcome is true. This in turn, however, means that we will route, or the process engine will route the token to task B. And for this process instance, we can never reach task C. For the input Bob, we can never reach task C because of this table. So in turn, this means it is not necessary to compare the tables assigned to task A and the table assigned to task C, because for one process instance, we will never have decisions made on the basis of these two tables because of how the process is routed. This becomes even more obvious if the BPMN model becomes more complex. Instead of comparing all DMN tables, we form this decision history where we trace the route of a token through the process model. And only those tables which we actually pass on our route for the process instance, these decisions are stored in the decision history, and we check then this decision history for consistency. As you can see, only the decisions or the tables which we passed for this process instance are involved in this decision history and are consequently checked for consistency. I'd like to cover one last point about inconsistency measurement. As you saw maybe in the demo paper, our approach doesn't only detect inconsistencies but can also analyze inconsistencies, meaning that we provide quantitative insights over the severity of inconsistency. So let's go back into Camunda and look at another example. Let's start another sample process. Let me just quickly show you how the process looks. We have a simple input of a name and an age, which is then processed by a business rule task. If we look at this DMN table, we see there are several entries, and we can also see that these entries will probably cause some inconsistencies because there are overlaps and contradictory outcomes. So let's again just see what happens if the employee enters a new case for Anna. As we can see now again, an inconsistency was detected. And we'll jump into the plugin tab to see what it's all about. And now here on the top you can already see the quantification or the inconsistency analysis. We'll pop up the table. You can see that the colors in the inconsistency analysis on the top match the colors from the table to help modelers quickly find the rows. And you can see that we have here these inconsistency values indicating the degree of inconsistency. As we can see, row 3 is the most inconsistent because row 3 contradicts 2 rows, whereas the other 2 rows only contradict row 3 but are conformant to each other. So now the user can choose to resolve this. Let's just say we want to delete this one row and change this one other row. Upload it, so the DMN table is now deployed again. And we see in the BPMN model or in the process engine, it was again rolled back as before. So let's see what happens if we enter this user task again and enter Anna. As we can see, there are no inconsistencies anymore because we successfully altered the tables to be consistent now. And as we can also see, this means in the Camunda cockpit, we don't have any incidents anymore and the process is now running nicely. So this was our tool to monitor consistent decision making in business process execution. I hope I could give you a little insight on how this plugin works. Thank you very much for your attention and see you next time.